And this is mainly about how to solve system of equations. So this one is focusing on system of equations with two variables. Normally we use the graphing method, the substitution method, and the addition method. Graphing is okay as long as your answers come out to be integers. So if they are just, you know, -5, +2, and stuff like that, it's okay. But what happens if, when we're talking about solving these systems and they end up at a point, which happens to be a fraction, because sometimes you can end up getting 11 over, I don't know, 15. And the other coordinate can be like 7 over, I don't know, 21. Oh, that one simplifies. But it's hard to pinpoint these values when you're doing graphing. So graphing is something we don't really like to do when we're working with solving system of equations. So it's mainly substitution and the addition method. Now the idea is if we have two equations in two variables, you can end up with three different scenarios. Either the two lines will end up intersecting at one common point. So that will be your x and y coordinate, which means we only get one solution out of this system. We say that system is a consistent system. We have independent equations, and usually that also means your lines have different slopes. Now, the second thing that can happen, they can be the same line. So they can basically be overlapping lines. And if they are overlapping lines, which means all points are basically a points of intersection, right? Because they're the same point, which means all those points on the line will satisfy your system of equations. So again, we say it's a consistent system, but in this case, the lines are dependent. Because normally what happens is you can take one equation multiplied by some constant and get the other equation, or you can divide the second equation by some constant and get the first equation. So we say the lines are dependent, or actually the equations are dependent, and of course we have infinitely many solutions. Now these ones, if you put them in your slope-intercept form, they will end up having the same slope and the same y-intercept, which makes sense, right, if they are the same lines. The third thing that can happen is obviously the lines don't touch each other at all. You end up getting parallel lines. So if they're parallel lines, we say the system is inconsistent because obviously you will have no solution. Parallel lines we know never touch, never cross each other, which means we won't have any solution. And usually for lines like these, you end up getting the same slope with different y-intercepts. So if they are the same line, same slope, same y-intercept, if they are parallel lines, you have the same slope but different y-intercepts. And of course, if they are going to intersect at one point, usually they will have different slopes but also different y-intercepts, unless they're meeting at the same y-intercept, okay? So substitution method is basically where, remember, you take one equation and you literally put it inside of the other one. So we're substituting by taking one equation and putting it inside of the second one. So that's what substitution does. The addition method, some textbooks like to call it the elimination method. So the addition method is where we try to find a way to add the two equations together in such a way that one of the variables eliminates. Okay, so that's why you will see textbooks using one name or the other. So that's the two methods we're really going to be concentrating on, is the substitution method and the addition method. So like I said, 5.1 is just a review section, so we're not really doing anything. There's no homework. You won't be tested on this section. So what I actually want to do is work with 5.3 first and then come back to 5.2. So if you will actually get your 5.3 handouts, we'll work on that first, and like I said, come back to 5.2. So this one, we're actually starting out with dealing with non-linear system of equations. Same idea. Instead of having these equations represent straight lines, we're talking about non-linear. So they can be parabolas, they can be absolute value, of course, cube roots, any of those functions which don't have graphs as straight lines. But the solving process for this will be very similar. So we can do substitution, we can do addition. Obviously, we're also going to be looking at graphing with this. So your nonlinear examples, can be a parabola, y equals 3x squared. Of course, your square root function, absolute value function. We just talked about these in chapter 4, right? Exponential function and logarithmic function. So all of these are examples of nonlinear equations. So let's see, we're actually starting out with a straight line and a parabola here. Now, since these guys are nonlinear equations, that means they can intersect at more than one point. Some equations will only intersect at one, some of them will be more than one point. So it just kind of depends on what kind of functions we have and what their graphs look like or what kind of solutions we get. So we're starting out with graphing here. So we have y equals x squared and y equals x. So we'll create a table for both the functions. Let's start with our parabola here. Again, these are pretty straightforward examples. So hopefully we should not have to do too many different points. I think these 5 points should work for both of them. You can use the same for the y equals x. So can you tell me what values we get for the x squared function? With -2, what are we going to get? 4, -1, 0 will be 0, +1 will be, and +2.
4.
Alrighty. Y equals x, that basically means it's the same value, right? Because we're saying whatever is x is the same value for y. Remember, we also call this guy as the identity function because your x and y values always end up having the same exact number. Okay, so you guys can go ahead and start graphing them. Make sure you label each one of your graphs. So we've got 0, 0, 1, 1, 2 and 4, -1, 1, -2, +4, so that would be our parabola. So that's our x squared function. For our y equals x, again, we have 0, 0, 1, 1, 2, 2, -1, -1, -2, -2. That's our y equals x function. Hopefully you guys have a little bit of a better graph than I do. But where are we noticing the two graphs intersect at?
Origin and one.
Yeah, so they should be intersecting right here at the origin, and you can see that's the point which we also had in our table. And the other point where the two graphs are intersecting is at 1, 1. So you should be able to verify that. Now, one thing we normally like to do when we work with the system of equations is to check our answer. And normally, for checking our answers, you can just take your ordered pairs and plug it into both the equations and make sure you're getting a true statement. So if we start with y equals x squared, that's going to be 0 equals 0 squared, which we know is going to be a true statement. If I try this with y equals x, of course, I'm going to end up getting 0 equals 0, which is also a true statement. So we know that point checks out. If we do the same thing for the 1, 1 ordered pair, you are again going to see true statement for both equations. So checking is something we normally try to do as a way to make sure our graph was obviously graphed correctly. If we were doing this by the substitution or addition method, again, we want to make sure our math was sound. Any questions on number one? So when you're writing your solution set down, normally remember we used set notation. So since we have two ordered pairs, you're going to write it as 0, 0, comma, 1, 1. So both of those, just put them together with a comma separating them. Okay, same kind of thing happening on number 2. We are given y minus x equals 3 and y equals absolute value of x. And they're also obviously asking us to use the graphing method. One thing I would actually do is rewrite that first equation, just move your x to the other side. So simply add that x and get your equation as y equals x plus 3. Now you can use a table to try and graph this, or you can use the slope-intercept form. So if we use slope-intercept, this is our y-intercept, which is the point 0, 3. Our slope, of course, is 1. So you can write it as 1 over m, right? Go up 1, go right 1. So you can use that. Or like I said, if you wanted to do an XY table, you can do that also. For absolute value function, just going to use a table for that guy. So go ahead and tell me what those y values come out to be. So what do we have for those y values?
We have 2, 1, 0, and 1 and 2.
Yeah, remember absolute value makes everything positive. So positives will stay positive, negatives will become positive. Okay, so starting with my first equation, our y-intercept is at 0, 3. Now you can go up 1, right 1. You can also go down 1 and left 1. However you want to graph that. It's kind of nice to have an x-intercept so we know where our graph will be crossing the x-axis at. So it should be crossing at -3. So my line's a little off, but hopefully that will still work for us. Your absolute value, of course, is at 0, 0, 1, 1, 2, 2, -1, 1, -2, oh, -2. I don't have my graph. That's not where it intersects, does it? No?
Intersects at 1.5 joules.
Okay. Something like this. Okay. I can see from my graph's a little off. Hopefully, I'm hoping you guys can have a better answer. Where are the two graphs intersecting at? They're not integers. -1.5?
Yeah.
And what's the y coordinate? Positive? Yeah. So you should be at basically -3/2 and +3/2 if we write them as fractions. If you want to write them as decimals, it will be -1.5. I believe they normally want fractions as your answer here, but obviously you can always work backwards to see what works for you. So just one place where they're intersecting, right, in the whole system. So let's do a quick check here. So with our first equation, y minus x equals 3. Yeah. So that will be y, which is positive 3/2, minus x, which is negative 3/2. So what happens there? Two negatives make a positive, right? So you'll basically have 3/2 plus 3/2, which is 6/2, which is of course 3. So you get a true statement for that one. If we check this for the absolute value function, that's 3/2 equals absolute value of negative 3/2. Again, we know absolute value is going to make it positive. Which will also end up giving you a true statement. So since both our equations check out, we know that's our solution set. So first example you saw, we got 2 ordered pairs as our system solution to the system. This next one, we only got 1 ordered pair. And like I said, it just really depends on what kind of equation you have, what kind of graphs those equations will have. So I'll give you guys about a minute or two. Let's see what those graphs look like and what your system solution looks like. So this one is absolute value of x and y equals x squared as your 2 functions. What do we see?
That's 3.
3 points? Okay. So your absolute value function, and then our x squared. Something like that. So where are those 3 points, Trey?
Negative 1, 1, 0, 0, and 1, 1.
Very good. And again, you should be able to verify those points on our table also, right? So there were the 3 same points. Again, I'm actually not going to take the time to do the check, but obviously make sure we do that, which means our solution set is going to be those 3 points. Okay? Questions on number 3? All the examples we did with graphing, we had fairly easy numbers to identify. Luckily, our fraction came out to be a number that we could easily identify. Like I said, sometimes those fractions are just really weird looking numbers, so it's hard for us to know where the points are intersecting. So let's get into the other 2 methods of substitution or elimination. So here, do you know what kind of equations these guys are? X squared plus y squared equals 5. X squared plus 4y squared equals 14. The first one should be easy to identify. It's a circle, people. X squared plus y squared equals r squared, right? Okay, the second one you may not be familiar with, and that's mainly because of that 4 on the y squared. That's actually an ellipse. Okay, so think about in your head, and we're not using graphing here, but if I take a circle and intersect it with an ellipse, we're expecting to see 4 points, right? Where the 2 graphs are going to intersect. So when we are taking a shape like this, we should expect to see 4 points. So let's see how we can go about solving an example like number 4. And we're actually going to try using the addition method in this case. So we've got x squared plus y squared equals 5. X squared plus 4y squared equals 14. So remember, as I was mentioning earlier, when we are working with the addition method, the idea is we want to add the 2 equations in such a way that one of the variables cancels out or eliminates, okay? So the easiest variable I am seeing here that can be eliminated is actually our x squared. Because as long as I can make one of these a negative x squared, positive x squared, negative x squared will cancel each other out. So what we're actually going to do is take our first equation and multiply the entire equation just by -1 so we can get that negative x squared. So keep in mind that -1 will multiply with the entire equation, okay? You could have also multiplied the second one with -1, but I just wanted to keep my numbers positive, so that's why I used -1 on the first equation. So we end up getting negative, actually, you don't need to write that. Negative x squared, negative y squared equals -5. Keeping the second equation as it is. So that's x squared plus 4y squared equals 14. And now we're ready to add the 2 equations. So now that I've made one of my x squares negative, these guys cancel out. What's -1 plus 4 on the y squared? 3y squared. 3y squared. And 14 minus 5? 9. And again, our goal ultimately is to get y by itself, so start by dividing both sides by 3. So what do you think the value of y is going to be if y squared equals 3? Yeah. So we end up taking square root on both sides to get rid of our square. And remember, anytime we take a square root, we get one positive and one negative root. So we end up getting plus or minus square root of 3. So 2 values for y. So for each of the values, we basically now need to calculate what the x is going to be. Alrighty, so now let's find x. We'll start with positive square root of 3 and then come back and do negative square root of 3. And I think I'm actually just going to use my first equation to find the x. So that's x squared plus y squared equals 5. So substitute for your y as square root of 3. And then of course, since we have that square already in there, it actually helps us clean up the square root. So this square will cancel out that square root of 3, leaving us behind with x squared plus 3 equals 5. Go ahead and move that 3 to the other side. So again, what kind of values are we looking at for x? Right? We should get 2 answers again because we end up taking a square root on that x. So this actually means from one value of y, we ended up getting 2 values of x. So that's going to be 2 ordered pairs. I have positive square root of 2, and this was coming from the y value of positive square root of 3. So that's one ordered pair. And then the other one will be negative square root of 2 for the positive square root of 3. So from one value of y, we're getting 2 ordered pairs, 2 values of x. If you go back and redo this calculation now with the negative square root of 3, we should again expect to see 2 values for x. So now let's do y equals negative square root of 3. Again, I'm still going to use my first equation to find this. So replace your y with negative square root of 3. Okay. Negative times negative? Positive, right? So here's something, either you write it out or just remember that you are basically taking a square on that negative square root of 3. So negative times negative will become positive. And additionally, the square root will cancel out the square, right? So you will again end up getting x squared plus 3 equals 5. Subtract that 3. And we're basically going to see the same result from this side as well. So we will again end up getting positive square root of 2 with negative square root of 3, negative square root of 2 with negative square root of 3. Those will be our 4 different points where these 2 functions are intersecting each other. On paper, you can write it like that. But keep in mind that's 4 different ordered pairs. Okay. That's our addition method where you're basically adding the 2 equations so that we can cancel out one of the variables. Question on 4? Number 5, again, we're actually going to try and use the addition method again here to try and eliminate one of our variables. So let's go ahead and take a look at how something like that would work. Now, we are not going to try and get rid of our denominators. We're not going to try and find common denominators to, rewrite those equations. We're actually going to leave them in the form they are. And one benefit we have in this equation is we already have opposite signs on our y term. So since we have opposite signs on our y term, the idea is if I can get them to be the same term just with opposite signs, I can cancel them out. So if this guy is positive 2 over y, and we can make this one into negative 2 over y, they will cancel out because they'll just be negations of the same term. So for that, we're actually going to take our first equation and again, multiply it by 2. If it helps you when we're working with fractions, you can think of that as 2 over 1. Okay? So basically, we're multiplying by 2. So 3 times 2 will give us 6 over x, minus 1 times 2 is 2, so that's 2 over y, equals 13 times 2 will be, yeah, very good, 26 over 10. Don't reduce that fraction because my second term also is 9 over 10, so if we can keep the same denominator, we can work with those terms easily. So second equation, we're keeping it as it is, 1 over x plus 2 over y equals 9 over 10. And now we are ready to add both these equations. So as I was saying, you've got 2 over y and 2 over y. One is positive, one is negative. So they will now cancel each other out. Okay. So 6 over x plus 1 over x, what will that give? 6 over x plus 1 over x. You've got that common denominator of x, right? So 6 plus 1, 7. So you will end up getting 7 over x here. And 26 over 10 plus 9 over 10. Yeah, 35. Again, don't try to reduce that fraction. Leave it as it is for now. All right, so we've got 7 over x equals 35 over 10. What do you think we should do? Or? Yeah, you can actually just cross multiply. Think of this as proportion. So you can do it that way because you're trying to get 35 on both sides, basically, isn't it? Yeah, you can do that or just do a cross product. It will get you to the same result. So you can try it either way, whichever one seems to work the best for you. So that's going to give me 35 times x equals 7 times 10, which is 70. Divide both sides by 35. X equals 2. Very good. And once you have your x, we can go back and find the y. Looks like I used this second equation. Obviously, you can use any one of those equations to find y. So if x is 2, that equation will become 1/2. So again, we're trying to isolate the y term. We want to get y by itself. So start by first subtracting that 1/2. What should we do to subtract 9/10 minus 1/2? Yeah, get a common denominator, so multiply this fraction by 5. Once you have your common denominator, you can subtract, which will give us 4 out of 10. Very good. Same thing, cross multiply. What's that? 4y equals 2 times 10, which is 20. So what is y? So again, our solution set will be 2, 5 as the ordered pair. Okay. I'm actually going to skip number 6, but I do want to show you how number 7 works out. So this one is talking about two complex numbers whose sum is 6 and whose product is 10. So here we're talking about two numbers that you add up, which gives you 6, and multiply to get you 10. So how do we work with something like that? Because this is actually something you will see on your homework and your test. So two complex numbers, let's call them x and y. They're telling us the sum of the two numbers is 6, right? And the product of the two numbers is 10. So that's actually what your equations end up looking like. So what do you think we need to do to solve something like this? Can we use the addition method? No, right? Because there's really no way for us to cancel out either the x or the y, since the second equation is x times y. So this is actually where we use the substitution method, okay? So let's call this equation 1 and equation 2. So the first thing we actually need to do is rewrite equation 1 either for x equals or y equals. So isolate one of the variables. It looks like I actually got y by itself. So if I want to get y by itself, that means we're moving the x to the other side. And we're rewriting that first equation as negative x plus 6, okay? And then we are going to substitute equation 1 into equation 2. So we're actually going to take this value of x minus 6 and replace it for y in our second equation. So that's how the substitution works. So we will have x instead of y. We're going to replace it with the value from the first equation. And this equals 10, right? So instead of y, replace it with negative x plus 6. When you're working with the substitution method, make sure at this point when the substitution is done, that only one variable is what you see. So if we're putting everything in terms of x, there should be no y at this point, right? If both variables still show up, then obviously we did something wrong, okay? Alrighty, so here, obviously we need to start by distributing that x inside the parentheses, and we'll actually set it to, well, can we set it to 0? Let's see. So this guy will give us negative x squared plus 6x equals 10. Basically, you see, we're kind of looking at a quadratic equation at this point. How can we solve a quadratic equation? Factoring,
Or quadratic.
quadratic formula, or
complete the square.
or complete the square. So at this point, it's actually up to you which method you think will work and how you want to solve it. So I would actually go about by setting this equal to 0. Normally, we don't like leaving our x squared as a negative term, so I'd probably move everything to the right-hand side to start by adding the x squared, subtracting the 6x. And just putting it in the order, so I would have positive x squared minus 6x positive 10. So let's think about factoring first. Factors of 10 that would add up to give us negative 6. No, right? Because 10 is what? 10 and 1, or 5 and 2, and none of those combinations will add up to give us negative 6. So at this point, you either do completing the square or you do the quadratic formula. So which one? Quadratic formula? No? You want to do completing the square? Because those are your two choices. Okay. 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 So that's negative of negative 6 plus or minus square root of negative 6 squared minus 4 times a, which is 1, c is 10, divided by 2 times 1, right? Putting in our a, b, and c values. Go ahead and simplify that and see what you come up with. What do those answers come out to be? It's 36 minus 40.
It's negative 4.
Negative 4. How do we simplify negative 4?
2.
Yeah, square root of 4 will be 2, and then square root of negative 1 is our I, imaginary number. And then you're just simplifying, so you can do 6 divided by 2 plus or minus 2i divided by 2, which ends up giving us. So when they told us we have 2 complex numbers, there was a good chance we could end up with imaginary. Now, sometimes you may still end up with real numbers. They are still considered complex. But when we couldn't factor it, you were either going to end up with irrational numbers or you were going to end up with imaginary numbers. So our 2 numbers are basically going to be 3 plus I and 3 minus I. Okay. Questions on this one? All right, guys, so this is where we are going to stop for 5.3.